Welcome to an end-to-end hands-on of integrating sensors with LoRa and the Things network. I do this hands-on as part of the Things virtual conference, the 16th of April 2020. This hands-on will be available as video so that you can repeat it or do it later again in your own pace. So let's see here. Everything very live. I am Andreas Dyrbeck, software developer, professional software developer with a bachelor degree in computer science. I am, next to a profession, a software development, fascinated by electronics, sensors, and not at least the possibilities that LoRaWAN offers. I run a small company called itoffice.eu, where I offer services in software development and products for IoT. So we will look at, or I'll try to follow this, what we have here, how sensors communicate, or how we communicate with the sensors, seen from the sensor side, microcontrollers. I already have picked some and have some advice on that, you could say. How to connect the sensors with the microcontrollers in form of hardware. There are different approaches. You select what you like. And of course some software for programming the microcontroller. There are some tips there also. And we will do quite a few programming examples so that you see how it can be done, or what the possibilities are. And we will, of course, it's LoRa, so we will connect to the Things network, and from there we will make an application that routes the data to another server somewhere where we can see the data, graphs, some nice stuff. End up with a conclusion. Let's see if we get there today. So that's the program. I hope I don't forget anything. It's live, you know. So how sensors communicate? There are a ton of communication standards, and some of those you will meet very often are I2C, also called I2C, whatever you like there. And that could, today we will look at the BME 280. There is a 180 also, whatever, it's both I2C, or it's a BMP 280. That's the same, more or less. Few differences. And regards to one wire, we will try out the DS18S20 or DS18B20. There are, again, a couple of different models. They work the same, one wire, actually. And they are temperature sensors. The DS18S20. I have them in two form factors. We will see both. Okay, let's go on to the microcontrollers. As that's what sensors now, microcontrollers we have. It's about finding some microcontrollers that work with LoRa, and some of them are integrated in the LoRa sending unit is integrated together with the microcontroller, so a small CPU. And that can look something like this. This is the TTGO LoRa 32, which is equally in pins configuration, like the Heltec Wi-Fi LoRa 32. So they are swappable in version 1 at least of these. And you can find something like I have it here, the CubeCell. It's from Heltec also, and that's the development board. And there is, if you order it as a development board, otherwise you will not be able to use it. So that's what I'm working with, and there exist possibilities for Arduino also, where you can connect some stuff on the Arduino, so you can send LoRa with Arduino. There's a bunch of electronics out there, and what I want to try out one day is also the STM32 boards with the LoRa possibility, but I've just not had the time yet. I don't have the hardware, so it will come one day. And there exist others. We will work today with the Heltec Wi-Fi LoRa 32 in the version 1. So next thing is how to connect the hardware, the sensors with the microcontroller. And we can take a look at that a little bit. That's a breadboard. And down below, the plate down below has these connections. Now this is turned 90 degrees. The top up here on the left and the bottom here on the right. And you somehow maybe grasp the idea. This is the bottom plate. And these are the holes that are above it. So you would maybe take some sensor, and here are the pin outs. There's the supply of the sensor, there's a ground, and then there are two others for communication. You would put it in there. You would take something like these DuPont wires, or whatever they are called, and you would place maybe power here, and you would say, okay, let's make the red one, no, it's black and white, but let's make the red one power. And you would take the power from the microcontroller here. Now, I don't know where the power is here, but let's just imagine it's the second one. So the power would run from the microcontroller, fed by the USB, over here to the right line of these two, down here into this one. You would need a ground also, at least, so the second one would be ground, and you would put that on the blue one over here somewhere, and then you would connect it to the ground of the microcontroller, and that is maybe number 1 up here. And you know, let's do the second. You have something like this, and then you would find the pin out for the microcontroller development board, and you would find the SDA line for the I2C and the SDC or clock line for this communication standard. So we can now, this is the Heltec Wi-Fi LoRa 32. Let's just find that on the internet. So we would write Heltec Wi-Fi LoRa 32 pin out, and we'll find different stuff here. I know where it is, so I'll go for it here, more or less. This is the version 2. I don't want that, I don't have that. So I'll just take the pin out here, and then I take version 1. And here I can find the pin out, and ground is the first one, 5 volt is the second one, so I actually want that on the third one, 3.3 volt. And then I can find the SDC, that is the I2C. Is this, where are we? Where? Okay, it's okay, we will use these two. You see here on the left, it is called 15. It is on the left side, the 5th from below, from the bottom. And here we have the OLED SCL. So it's the clock line that is used for this OLED, the screen display you have here on the top. So this is the clock line, and we have the SDA here for the OLED also. So we share this I2C bus. We share that with the OLED, and because the OLED has a identification number, and because our sensor has a different identification number, because of that we can distinguish between these two and send one command to one of them and another one to the other. But we share the bus, the I2C bus, the I2 bus here. So that would be 15 and 4. Now I will not go in to do that now, to connect that, because you can imagine what you want to do, what you need to do. You find more wires of these, and you will then connect them according to the pinout of the microcontroller and of course of the pinout on this sensor. Let's see what we have here. Let's turn around. On the other side I see are they labeled with walled in, etc., etc. So yeah, that's the way to do it, you know. And you have here the DS1820, and you would do that accordingly. There is a ground, one of them is ground. You find the data sheet. Let's just find the data sheet for the DS1820. Let's do that. So it's about search, and we will DS1820 data sheet. And that's could be here. Let's take, what do we take? It's a Maxim, yes. Maxim integrated, they have made it. A little bit of zoom. Let's take that. So here's the data sheet, and let's zoom again, and we can see the pin configuration here. We can see we have a ground, we have a data line DQ, and we have the power VDD. So these three pins correspond to, if you look at this chip from the bottom view, it says here, but the bottom view, and you can see pin 1, pin 2, pin 3. Let's just take a look at that on our sensor. So there is a flat side, and I'll try to put the flat side the same way, and then I have pin 1, 2, and 3. So they are numbered, and according to, or yeah, labeled on the data sheet, and there you can find the connection. So you know ground to the ground at the microcontroller, and VDD to the power, and the middle one, that is the one wire connection. And many microcontrollers, you can decide which one you want to use for one wire. And I would say with this Heltec, use 17. That's one possibility. You can use 12 or 13, the pins or GPIOs. Data sheets, one of the keywords in the data sheets, you will find all the information about how a sensor works. And for programming it, you often need libraries. They will be mentioned in the tutorials. Take this library, use that, etc. So that's a little bit about finding this stuff. So you can work with breadboard, and you will end up with, you know, a bird's nest somehow with some sensors inside, and you know, and then you'll find a tutorial, you'll find some software, and we'll come to that now, how to program this bird's nest. Now, I don't want to use the time to fiddle around with this. Let's take these wires out. I will say I've prepared something. They always say when cooking. So let's just replace this board with this. This is just wiring, pure wiring. I will replace this board with this one. So this is just wiring, nothing less, more or less. Just there's a transistor here to turn on and off the power, but for the sensors. But anyway, it's the same, it's just wiring. And I will take these wires and exchange them with this. So this is, except for some of down here, works now. For now, what we're doing now, it's only substituting these wires. And this goes into here. And this goes into here. I can be careful with the screen. If it breaks a corner, it will not work that well more. So I have here the same as if you have this. just I very often put in sensors, take them out, so I've done this now. So it's faster for me to work with this as a platform. So what do we have here? These sensors, I'll use one of these. It's the same. These two are the same. I already know I have the I2C connector over here. Just check that it is right. Okay, so this is the I2C bus I have over here. And so that was one. Then I have the DS1820. I have the same here. It's the same sensor. I just put it on a small PCB, so it has these connectors, because I work with this from time to time and I have to take it out, put it in, and this has a space over here. That's where I have the one wire bus. Okay, and that was this one. Then we have once the LM35, and happens I have put an LM35 on this PCB, and only there's nothing here. It's just wiring. It's just wiring. You know, this is just replacing this. So just I have here a fixed connector. So, and I have some spaces here. The sensor is the same. And I'll put that in here on this channel. So here I have 4 channels for analog sensors. And we are in this program. We want to check what is this Arduino IDE. So an IDE is simply a program you use for developing software. So it helps you develop software, it supports you in different ways. And the Arduino IDE you can use for not only Arduino hardware, you can use it for a ton of other microcontrollers. If you go into Tools and you go down to Board, you can actually here find a ton of boards. Not only Arduino IDE, Arduino boards, a ton of other boards. And now we have the Heltec, and it's actually also shown in the tutorial. We would need to go in and add the hardware support for this Heltec board, or add the hardware support some things to the Arduino IDE we have to add, so that the Arduino IDE recognizes the microcontroller you work with. So if you buy a microcontroller, check out that it is supported in the Arduino IDE, I would say. An Arduino IDE is a very good place to start for developing software. There are others. There are at least three others platforms, IDEs you can use for developing your C/C++ software. But this one is I would say the easier to start with, and you can always change later on if you like, no problem. The program language, C/C++ is the same. So you would go into Preferences, and now you can't see that window. I have to, okay. Well, let me take that in the tutorial here, where we have that. In the beginning. No, we will take it here. 1 second. Let's make it consistent. So we make the Arduino IDE ESP32 hardware support. And what can we find here? Here, for instance, installing ESP32 on the Arduino IDE, and it's even for Windows, Mac OS and Linux. And there's a video how to do it, and you need the Arduino IDE installed, and then you go on Preferences in the Arduino IDE, and on Preferences you can go down to this additional boards manager, where you put in a certain sentence. If you push the button on the right side of this line, they will open another window where you can put in different lines, more than one lines. And then they have here the example of what will you put in for the board ESP, or the microcontroller development board ESP8266. And there is a line also for the ESP32. Even that. I think this is the same for both of them. There's two here. We can see this is for the first one, the ESP32, and this is for the ESP8266. So there's already two in this line. You follow a tutorial like this. Very simple, you know. That is how you will install the hardware support into the Arduino IDE. And when you have done that, let's go into the Arduino IDE again. So let me find the right window. If you have installed that, you would go into what they show down here. You would go into, I can't show it right now because of my setup. I can't show it on my own Arduino IDE. But you will then go into the line Tools, down to Boards, and then over to Boards Manager. You wouldn't have seen that before, because it's how it works here for me now. I can't show you that. So it's very good we have this tutorial. And on this Boards Manager, the first line there, you would could go in and search for instance, ESP32. And then something would pop up here, and you say, okay, I select that, and on the right side you would simply install it. Should be installed after a few seconds. Exactly, you need an internet connection for this. And then you can go in and see if it's there. You know, you would go into, you would say, okay, close the window. You would go into Tools, Board, and then you will, on this list, you will select the development board you are working with. For instance, a Heltec Wi-Fi LoRa 32 version 1, or a TTGO Wi-Fi 32, for instance. And if you have selected that, then there will pop up some other possibilities for doing some selections on communication speed, etc., etc., etc. So that's how you install the hardware support and select the board you work with. And yeah, it's a pity I can't show it to you because my software right now don't show the windows that open when I push on it in here. That's a little bit of a pity, but there are videos for that. Anyway, I would expect you now to have connected the sensors with your development board, for instance, based on ESP32. And you would have installed some sort of hardware support. If you don't use an Arduino hardware, you would install the hardware support for the ESP32 somehow, or development boards, the Heltec or the TTGO, and you would now be in the position where you have chosen, like here, where you have chosen the right development board, and where you can select. It's very important that you go down and on your port. Now I have already connected my development board to my computer, my USB connector, and if you've done that, you will find in the menu under the topic port, you would select USB 0 or something like that. So you have to select the right communication port, and on Windows it's called COM something, 1, 2, 3, 4 something. So you have to select the right one there before you can communicate with your development board, microcontroller. Let's just say you have that now. Or you will work it out very soon. I have this scanner software here, so I want to scan. I want to install that. What do I do now? How do I show you that? I have to find it on the internet. It's horrible. you know, because the software don't want to show that now. So flashing, exactly. Yes, the upload button. The upload button is the second button in the Arduino IDE. So it is up here, you can see that. And the one to the left is a verify button. It only compiles the program but does not upload. And the second is an upload button. And now I have written the program. I will talk about it in a second. So if you push that, it will start to do some things down here. It will compile. It will tell you what libraries it has used, and it will upload it. And it will reset the microcontroller so that you would be able to see some things happening. You know, the blinking for this part here is the Heltec. It has a blinking LED here if it runs. I can see there's power on this board down here. And what do we do now? Can we see anything? Yes, we can, because in the Arduino IDE we can go on tools, we can go down, pushing the menu tools, going down on serial monitor and click there. You could also, instead of using the mouse, you could hold down, on Linux at least, Control Shift and push M. Would be the same. And we would see a serial monitor. Let me find it here on my... You would find a serial monitor like this. And it would maybe even be on top of your program. Like this. And something comes out here. It's a scanner. The software scans the one-wire bus for IDs. And we have one. This is this 10OE8C41030800FF. That's an ID for one wire. Here it is. I just need to push the right buttons. So here you see it. This is it. This is this 10OE8C, etc. That's the address. That's the only address on the one-wire bus. It scans again and again. So if I put in another sensor, it should find it. Let's try it out. You know, let's try it out. Table, session. Let's put it in here. Well, let's see what happens. And now I can see two sensors, two different IDs. Okay, so this scanner software, we can find IDs. Great, that's very good. That's very good. I already have that in another program. I'll just take this one temperature sensor out again. I have that in another program already. This scanner software, I put it in my GitHub. Well, you get a link later or somewhere else. The scanner software, it's a library, include wire 1. That's a one-wire library. You would initiate a variable called DS with pin number 17. So it will, the one wire will run over pin number 17. In my case, I have a separate pin for a power to power up the sensors. So you will not use that. Just yeah, ignore it for now. And then there's a section where it runs once to set up some stuff. Each time the microcontroller starts, it runs once. And then it goes over to circulate inside a loop. So just run this loop over and over again. And there is some definitions in the loop. And it searches and it prints out what it finds. It's not so interesting. Just so you know, there is a library, there is a small program for searching these IDs for the one wire. Let us change to not the scanner, but the software for this one-wire DS1820. And I have that here. So this is the program. And again, one-wire bus, pin 17. I include two libraries, and that is shown how to install these libraries. That is shown in this tutorial too. Let me find the section. That's up here. They actually more or less start with that. That was the hardware support. Still the hardware support. I have to install the libraries. We have some stuff there. Okay, it's not in that. No, it's in the other one. Here it is. Here it is. They have it. So, in this case, they install the SSD 1306. That's for the display. If you want to use a display, for instance, the Heltec or TTGO. It actually, if you want to connect any display, or not any, but most of the displays that run over I2C, you can use this SSD 1306. There are other libraries too. You would go in the menu. Now, me again, not switching. I'm talking, I forgetting to switch to the screens. This is what I'm talking about here. For instance, SSD 1306. That's a library for the screens. We don't want that now, but it's the same place you install libraries. You go to in the Arduino IDE. If I find the right one, I have so many open here. Yes, this is this one. You go on Tools. No, you go on Sketch. That's the middle one, and in the menu, and then you will go to Include Library, and another thing opens, and you will go to Manage Libraries. And if you open that, this window is popping up that you have here, more or less. And there is a field. I have to switch again. Okay, now you see what I see. This field you can search on the right top. You can search SSD 1306, or you can search other stuff. For instance, you can search for DS18 or LoRa, and that's a place where you install libraries. There are other ways to install it, but that's one way to do it inside the Arduino IDE. Libraries, they are placed a certain place. For Linux, Ubuntu, it's in the home folder. You will find a folder called Arduino with a big A, Arduino. And inside that you will find a folder called Library, and there you will find the libraries installed in Linux, Ubuntu. In Windows, it's another place, etc. But there is a certain place where these libraries are. And if you pull out the libraries, pull them out and place them somewhere else, the Arduino IDE will not find them, and they will be regarded as deinstalled. So that's a way to remove them. There's a certain folder for that too. So you can install it via this Arduino IDE library manager, or you can download from GitHub and then put the libraries in there equally to the other libraries, and then call them in the software with this include something there. And in C/C++, the .h file has all the stuff, or references all the stuff you need from the library. So you will not include .c++ or CPP. you will always only include the h.h file in these libraries. And often in these .h files, you will find the possibility to do some settings. That could be IDs, in the case of BME 280, etc. And here we recognize this ID we found before. I already put it in here. It can be different. The OX just tells the software this is a hexadecimal number. Oh, switching around different windows. Okay, now it works. So you can see this is the monitor, where you see these readings. Monitor, terminal, something like that it's called. You know, it's different. And you can also see in the bottom, you see this red text down here, that's also a terminal. So there are different terminals, but the monitor is part of the Arduino. And if you go on tools, down on serial monitor, this will come up, and you can see what you make with serial begin. This is establishing the monitor, the connection back from the microcontroller to the computer. And you use that for get information out if you don't have a screen on the microcontroller. So the setup function is running once and prints the stuff. It starts the one wire, it prints here just the text, degrees C, more or less. And then the loop runs. If we flash this now, the loop will run and we will get back temperature, etc. So let's just install this. I'll start with removing the, or maybe it was okay, it was there. Let's just flash this, and I do that by pushing this upload button up to the left, the second from the left. It's an arrow going to the right, and the text upload will appear. I'll push this, and you can see down here in this terminal window, you will see how it, oh, there's an error. While uploading, what does it say? It has no connection to this device. Okay, let me see what I can do. I go on Tools, down on Port, and I check if I have selected the device, USB 0. Now I have it. Now I have it. Now I know what's wrong. It is because the monitor, I have several Arduino IDE versions running for now, and the serial monitor is connected to one of the other programs I have in the background. I'm switching all the time. Transition. There you see it. So now I have this serial monitor running in the right, together with the right Arduino IDE window program. And this should now be possible to flash it. So I have chosen the right development board, microprocessor. In the menu, I have the monitor running based on this window I have here. And now it worked. It worked. That's wonderful. And we can see temperature, 30 point something degrees. I don't know if that's right. I don't know. I don't know. Maybe it's right, maybe it's not. Let me see. Let us just take the fingers and then heat the sensors while we see what happens with the temperature. Does it rise? Yeah, it rises. Yeah, it works. Is there really 30 degrees in here? Well, it could be. I don't know. I let loose again, so the temperature will fall a little bit. Okay, works. Well, we have the one wire, DS18B, DS18B20 or S20. We have it running here. We have the software here. and we more or less know what the software does, and it puts out the temperature. So you can now do the same. Let's speed a little bit up here. This is for the BME 280. It's an Adafruit library, and you can get the sensor at Adafruit too. There's this one for the display if you have a Heltec or another I2C I2C display. And here the library for the one wire. Some definitions of some things we'll pull out: temperature, humidity, pressure. I here define the pins for the I2C I2C bus. I here use some extra things for this connection, and that is because the display on this Heltec and TTGo uses these pins, so I have to do this setup. I don't have to, but I prefer to do it like this. I have here my own special power pin for the powering up the things. We have the setup here that that runs once. We put power on. We have the serial we start with. Here we check if we have a connection with the BME 280 sensor or BME sensor. Here we print out a heater line with some stuff, and then the loop runs where we read the temperature, humidity, pressure, and we print it out. This column add, that's just a function I've developed, and it just adds another column. Let's put it into run. Let's put it into the microcontroller. I'll start to flash it, and let's see what comes out. If it succeeds this time again. And let's see, we have this, and I'll probably have to set the monitor again. I haven't selected the monitor. Where's the monitor? So, tools, monitor. Doesn't work. It does not come anything back. So, program is not working, but it is like that very often, you know. Okay. Oh, it just pushed the reset button. Could not find a valid BME 280 sensor. Check wiring. Oh, yeah. And that's where we come to the very interesting point. That these BME, like the I2C sensor, like the one wire bus, the I2C sensors, they have numbers, they have IDs, and they are not in this. If you use the Adafruit library, they are not defined inside your program. They are defined inside this file. So I have now to find this file and check that I have the right ID inside this library before I can flash it again and see if it works. It's normally that problem. Okay, got it. I need it because now we have the display software inside. I'm sharing the I2C bus with the display, and actually activating the display in the software. I needed this one, display init, and it's because the display runs on the same I2C bus as the BME. So, and it simply needed an initialization. The BME begin init somewhere, or starts the conversation with the sensor somewhere else. If not, this is ran. So there are different typical places where you can make an error. You can maybe have selected, if you work with more than one development board, you maybe have tools board selected the wrong one. You could have another case is the ID of the if you use this Adafruit library, there is an ID in that file here that can be different from the one you use in I2C. And that's a second source of error, and this is a special, this case here is the display init because it uses the same bus I2C, like the BME and the display, they share the bus. And that's a third typical error place where it can be. So can take time to find these errors sometimes, but or not errors, but wrong settings or not correct configured or whatever. So yeah, now it works, and we can see data is coming out of it, and we can actually go through. I can reset it. Let's reset it. Thing. Okay, so that was the BME 280 software we see here. So we can now read into terminal, and when do we send this into the things network and the application? What do we do with these data? Okay, we can read them, and let me just see, what is the next one? That is the KTY81. And I guess I have to skip the KTY81 and the LM35, that are analog sensors. I'll do a separate video. I'll do them separately. I'll record it, and you will get those at another time. Next weekend, maybe. On my YouTube channel, you'll find it. We have to make it a little bit shorter. Was very ambitious. Anyway, and finally, have I made a software that incorporates or collects all these parts into one big chunk, where we have everything, inclusive the LoRa part. So the small chunks of software just reading from the microcontroller, I just do readings from the microcontroller to the computer, and this terminal, all these small parts are collected into one big, and I have integrated here in this one the LoRa software also. So now we will use that. We'll just say, okay, the sensor software works, and we can flash it to the board just to check that we get something out of it in the terminal. Let's do that. And now is this monitor window is connected to the right software window. So now we can flash it. So it's good to see me do these typical errors, so you get a sense of the typical errors happening in this. And they can happen several times during a day if you switch a lot. Okay, let's see. It is doing something. Can I make this window a little bigger? Yes, I can go on monitor only. And here you can see how this actually was started. Make it bigger. Yes, I can. And I'll just stop the auto scroll. So the program started, search for one-wire addresses, I built that in, and telling why it woke up, because it can have different reasons, the microcontroller for waking up, this one at least. It is the Heltec Wi-Fi LoRa 32, and it is set to sleep for 5 minutes, and then wake up and then do some stuff and send it to LoRa. And we can see what it reads here. It reads air temperature from the BME 280, humidity from the 280 and the air pressure from the BME 280. It reads the temperature from the KTY81, and it reads the temperature from the LM35, and that from the DS18S20 monitor terminal. So this we have to fill out, and we'll get that from the Things Network webpage. So let's log in, let's log out and log in. I have the app here. You would normally end up like this. 1 second. So here, when you log in, when you have an account, you would end up with this, for instance. Applications, gateways, that's the same buttons down here, applications, gateways. And I will leave gateways out for today. And let's go on to applications here. And I have made this application already. Let's make a new one. Let's call it live test. So this is an ID, and you will not be able to change that when you've done it. This is just a random one, not to conflict with other IDs. This is a description, I don't have to put it in, but let's just make test. So, and the application EUI will be issued by them. The handler you don't touch, and now we add this application. We have an application now. An application could be a customer, for instance. A company could have this, maybe, or a department that has a set of sensors. So, yeah, you use it for something, an application, you know. And in one application, you will have one or more devices. Let's make a device, and we will call it test device live, and then some random stuff here. And the device EUI, that be handled by them, by the Things Network. App key will be generated. App EUI we already have from before. And let's just register this device. Now, we have a device in an application, and this device is activated by OTAA, over-the-air activation. And I would like to use another activation method. So we go into settings. No, we don't go into settings. What do we do? Where is it? Oh, we go into settings. Here it is. We like to do ABP. That's where you pre-share the keys for your node, for your microcontroller sending in data. So we would like to do that. And we will disable the frame counter. Later on, if we have something running, we would like it. So for now, we just leave it disabled, and we have chosen this ABP now, and then we go down and save. And I have a poor internet connection right now. Oh, there it is, the green one. Okay, it has saved. So we have I have an application here with that name, test live something. We have a device. We can have many devices inside that application. We can have many applications next to each other. So, do we receive any data? Not yet. We have to put the codes into the software. And that's where we go back to the software and look, what do we need? We need the network session key. Looks like this. Hexadecimal numbers. We go back. And it is here, network session key. It's hidden. Now we can see them. They are somehow without this 0x something, all of them. And we could copy them over here. But if we push on this button here, or this square bracket, we can see it in hexadecimal style. And we get this. And we have to write less, you know. This is easier. Then we push the right button. And it's copied. We can go over to our program. Here. And then find a place for it. That is the network session key. And don't forget, here, at the end, we need the semicolon. So we need that here also. Oh, not the colon, the semicolon here. And then we need to remove this line. Like this. Now we have a network session key inside. Let's do the same with the application session key. App session key. We have it here. Let's look at it. Let's make it hexadecimal. And let's copy it. Insert. Don't forget the semicolon. Delete the other line. What? Here. Like that. And now we have the app session key inside. And we still need the device address. So let's find the device address. Where is that? Where is that? Oh. It's here, device address. This one. And again, you can get it as a hexadecimal. We don't want this as a hexadecimal. We just copy it like that. Go to the program. Here, I'll just take these numbers, eight positions, and insert it here. This should now work. And how do we find out? How do we find out? First of all, saving. Second of all, we want to flash this down to our microcontroller development board, and let's just flash it. Let's start the flashing. It will run. Let me go over to the and let me start the data. Here you can see on the web page of the Things Network, you can see the data that arrives, and there should arrive some. Oh, there they are. And this is the payload. There are a lot of terms here to remember. And they say there are no, you can see here there are no fields. It says there are no fields, but there are fields. I know it. And we have to select, if we go in the application, we have to select payload formats. And I work with Cayenne LPP. That is a format that you use with my devices. Now I selected that and I saved it. Let's go back to data. You can still see some payload here. Let's go to the into the devices, and let's go and select this device to the data. And now we should wait 5 minutes. We don't want, so I'll just reset the microcontroller and let's see what comes. Shouldn't take long. And there is the next line. And now you see something on the right side here. You can see it. It actually decrypts now and shows us the fields. So you have to be sure in the application to select the payload formats. In this case, Cayenne LPP. You can come up with others. And Cayenne LPP is a good place to start, even if you don't use my devices. It's a good format. It can be a little bit cryptic, but you have to save space here in this sending these data. You just send very few bytes over the air. Okay, data, we have them, let's look at them. And here you have, they come in as a little bit different. But you can see this 22, 23, 24. You can see this 9 and 8 and 7. These are, in Cayenne, they call it channel numbers. And Cayenne has a format that helps you a little bit, not entirely. But here it already knows, because I packed it in a special format, it already knows it's a barometric pressure. And it already knows here that it's humidity, has nothing to do with the channel. We can take a look at the program. But you can see the data arrives over here. And let's find the monitor and see the data in the monitor. Maybe they fit. And they do. They do fit. I haven't checked. But they do, really. Let's look at the program instead. It's a little bit more interesting. I have made a special place. I made a function for different stuff. Let me find it. Let me make this smaller. So, heater print. There's a function called heater print. It prints just the heater. And here I have a values print that prints the values in one row. And now we want where do we pack the data for sending them? We do that here. So this is a function called that will fill out, reset the variable LPP, and then add these things here. And here you can recognize the channel number 7, 8, 9, 22, 23, 24. And there you have to, that's where you see the KTY 81, that's 22. Then we have the LM 35, 23. And then the DS 18S2, that's 24. Okay, we receive data, and we don't really have time anymore. Let's just go back to the slides to see what we have achieved so far. So connect to the hardware. We talked about that. We talked about the software, about finding tutorials, programming in C, C++, Arduino IDE, installing hardware support, and libraries, how to install them. So yes, lean on the tutorials, and you will probably be saved very, very far. Programming example, we have looked on several. We didn't reach all, we didn't have the time for all of them. I will make a few more videos the next month. The Things Network we talked about, and the application example. We don't have it, I only have this 1 hour, so it simply doesn't fit in. I have to make another video, probably. And yeah, well, the conclusion is we achieved to see in sensors how they communicate, what standards exist, and that what we potentially should watch out for with the microcontrollers, what they're capable of, pin size, what they cost, sensors and microcontrollers, where you can get them. We looked at possibilities to connect the hardware. I chose an easy way. And then we looked at the software, the IDE for flashing microcontrollers, and we also looked at installing hardware support in the Arduino IDE. We looked at some programming examples where we read out the data from the sensor into the microcontroller, saw the sensor data in a terminal in Arduino IDE called a monitor. And we actually managed also to see a program from the microcontroller sending data into the Things network. We didn't have time for the application example, but I promise you I'll make a video for analog sensors with voltage divider, the LM35 and the KTY81. And I will probably make a video also with an application example how to send the data from the Things network to an application, another server, where you can see the data as a nice graph. So thank you very much for watching and staying here and bearing with me. This hands-on can be a little bit tedious, but if you start up, it can be valuable information for just making the first steps and the first experiences. You're welcome to join me on my YouTube channel for further videos. You can find me on Twitter. On my homepage, itoffice.eu, you can find more stuff and even the PCBs I've produced and using here. Yeah, thank you very much. See you next time.